Okay, guys, so here we go. Let's go ahead and start today. So the past couple days, we've been working with exponents, right? We've been talking about our exponent rules, okay? When we add, when we subtract, and we multiply, when the exponent of 0 equals 1. So today we're going to build on that a little bit and do what's called scientific notation. So write down the subjective for me real quick. I can write numbers in scientific notation and standard form. Standard form is just what we're used to. Okay, those are just our regular numbers. 10, 12, 20, 37, 0.5, whatever. So those are just our regular numbers, 100 million. Scientific notation is going to be the new thing. So I can write numbers in scientific notation and in standard form. Now, what does it look like? Okay, so I'm going to put two examples up here. Don't write this part, but hang out with me. So it might look like this. 2.4 times 10 to the 5th power. Another example might be 1.73 times 10 to the negative 3rd power. Okay? Both of those are examples of something that's wrote in scientific notation. Now, what it means is that we can write really big numbers or really small numbers. Now, today we're just going to work with really big numbers. Tomorrow we'll work with really small numbers. Now, what are some things that you notice? This is the most important thing, and I want you to write this down. So put scientific notation, and then we're going to put what do we notice below it. So the first thing that I notice when I look at this is that I have a number, right? When I start my scientific notation form, okay, I'm going to put a number, then I put a decimal point, and then I put all my other numbers that come after that. Sometimes it's 0, so sometimes it might just be 3. The other times it might be 2.4 or 1.73 or 1.7408, okay? But what's another thing that I noticed? I noticed that in my backup. So I noticed that 2.4, 1.73, 3, okay? I write this for me. I write all numbers until I get only zeros. This will make more sense when I do it, okay? So when I write this out, I want it to be a number, then my decimal point, then number, until I get to where there's only zeros. Okay? When I start doing this, it'll make more sense. The other thing that I notice is that at the end, it's always times 10 to some exponent. Okay? So I start with the number, decimal point, number, whatever, until I get to where there's only zeros left. And then I put times 10, and there's going to be some exponent that goes in that box. Like in the first one, my exponent was 5. In the second one, my exponent was negative 3. Okay? So let's keep working on it. Let's look at it here. All right, so how do I take a really big number and write it in scientific notation? So we're going from standard form, this is our normal part here, to scientific notation. Okay? Now, as I mentioned before on the last slide, we want it to be number, decimal point, number, whatever, okay? Now, in this first one, if I look at it and I asked you, where's the decimal point? What are you going to tell me? I don't see a decimal point up there. It's kind of like when we were talking exponents, and everything has an exponent of 1. The decimal point, if I don't see it, is at the very end, right? It's right there. Let's get it in a different color so I can see a little better. There you go, green, right there. Okay? Now, where do I want to move it to? Remember, I want it to be between the first number and the second number that aren't zeros. So the first number and the second number is right here in between my 1 and my 2. Because when I go to write this, I want it to be 1.2, okay? Because then everything else is zeros. You see after that? Once I get to the point where everything else is zeros, I don't write any more of the numbers. Okay, so now I got times 10. We just talked about in the last slide. But now I need my exponent. Where do you think my exponent comes from? My exponent comes from how many spots do I move that decimal point? So let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9. I move my decimal 9 spots. And each time that I move my decimal point, and this is why I write it like this, it's really multiplying by tens, which kind of makes sense if you think about it. Here's my ones category, right? How do I get from ones to tens? I multiply by 10. So that would be like this movement right there, right? That would be from 1 to the 10 spot. Now how do I get to the 100 spot? I multiply that by 10, right? So that's why it's times 10 at the end, because every time I move my decimal point, it multiplies itself by 10. Okay, what about this one down here? Okay, same thing like we did before. Where's my decimal point? It's right here at the end. Where do I want it to go? Between my first and second number. So I have number, decimal point, number, because I want my answer to be somewhere between 1 and 10. Okay, so my new number would be 3.34. Now this time I write 34 because it's not until after the 4 that they all turn into zeros. I know it's going to be times 10. Okay, let's count how many spots. 1, 2, 3, 4, 5 spots. So times 10 to the 5th power. Okay? Once again, just like I mentioned yesterday several different times, if you need to stop and pause the video to write down the examples, go for it. Okay? Let's move on. Let's look at a couple more. What about this one now? We got two different examples here. Same thing as before. Where's my decimal point? It's at the very, very end. Okay. Now, it's going to go between the first and second number. So I'm going to put 5. I want it to go right there. Now, my new number may be, okay, I could put 5.0 if I want to, or since there's nothing after the 5, what it really is it's just 5, right? 5.0 is the same as 5. So now how many spots do I move it? Let's find out. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9 again. 5 times 10 to the 9th power. Okay, how are we feeling about that so far? Try the next one on your own. Go. Do it. 10 seconds. Pause it. Stop it. Do it on your own. Let's go. Okay, so it's at the end, right? Decimal point at the end. Okay, I want it to go in between the first number. There we go. So my new number is going to be 9. You can put 9.0 if you want. Times 10. Now let's count how many spots I moved it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Times 10 to the 11th, okay? There will be my answer. Hopefully you're feeling good so far. So that was scientific, or that was standard to scientific. Now let's go the other way. Reverse, reverse. Okay? Scientific to standard form now. Okay, so I have my first one. 3.5 times 10 to the 4th. And here's how we're going to do it. I'm going to rewrite the number that it gives me to start with. So 3.5. Now, when we were doing it before, we counted how many decimal spots we moved it, right? And that was our exponent. So if I look at this one, my exponent is 4, which tells me that I need to move it 4 spots. Now, to make it a big number, okay, if my exponent is positive here, we're going to go to the right, because I need to make it a big number. Watch what happens. If I move it to the right, I'm going to go 1, 2, 3, 4. Now, what do you think I add in there? One of the things we noticed about these problems, they all have a bunch of zeros. So in each one of those blanks that doesn't have a number, we're going to add a 0 to it. So my new number is 3, 5, and 3 zeros, so 35,000. Okay? Tomorrow we'll work on negative exponents and you'll see the opposite. Okay, let's try this one. 2.45. Start with the number that they give me. 2.45. Okay? Now I'm going to go 7. We're going as positive 7, so we're going to the right again. You ready? 7 times. 1, 2, 3, 4, 5, 6, 7. Fill in my zeros. I like to rewrite it so I know my number. 2, 4, 5. 1, 2, 3, 4, 5 zeros. Which actually brings me to an interesting point. I just said 5 zeros. One of the biggest mistakes that people make is they think the exponent tells me how many zeros. Sometimes that is true. But in this one, it's not true. Look, I had an exponent of 7, and I only had 5 zeros. This time, it's not true either. 4 zeros is what maybe some people might think, but I only used 3. okay? So that does not mean how many zeros. It means how many spots I move my decimal point. Okay? Hope that makes sense. 2 more. Let's go. Let's try it out. Oh no! Crap. Go back. Okay. Try it again. Here we go. All right, let's try this one out. This is 6, right? So I got 7. Actually, 7.034. Start with the number they gave me. I'm going to move it 6 times. You ready? All right, let's try. Here we go. 1, 2, 3, 4, 5, 6. Fill in my zeros. And my new number is 7, 0, 3, 4, 1, 2, 3 zeros. There we go. Okay? Let's look at one more. One more, I think this is my last one. Okay, let's start with the number that they gave me. Now, this one's 5. Now, it's kind of like those ones that we did before where I don't know where my decimal point is. But just like any other number, it's 5 point. That's my number. Okay? How many times are we going to move it? 8 times. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8. Add my zeros. Okay. And my new number is 5. There we go. Now this time it does have the same amount of zeros as my exponent, which makes sense because as soon as I start, that's where I start making my zeros. Up here I had to skip 3 spots before I started doing zeros, so that's why that is sometimes true, but not always true, okay? All right. Complete these ones on your own. We'll check back after the video. Pause it and work it out. Okay, the first 2 you're going to do in scientific notation. The second 2 you're going to do in standard form. Okay, copy those on your notebook, and we'll come back together afterwards, and we will finish it up. Okay, I'm going to leave that up there for a few minutes so that you can see.